Topic that we are going to see is unions. Before this, we have seen what are structures. Structures was user-defined data types that could store different data types. Similarly, here union is also a heterogeneous user-defined data type that allows you to store members with different data type. The syntax for declaring unions is almost similar to structures. How do you declare a structure? Using the keyword struct. Suppose this struct is test, which has variables index, character y, float z, and s is a structure variable. Same way you can declare a union. You can define a union using the keyword union. Character x, integer y, float z, and a union variable u. Now the main difference between a structure and a union is in its memory location. You have already learned the memory location of structure variable. For integer x, when you are declaring a variable s, you have a s dot x 2 bytes, s dot y 1 byte, s dot z 4 bytes. So a total memory location of 2 plus 1 plus 4, 7 bytes are totally allocated. Now in the case for union, the memory space allocated is the maximum number of bytes for any of the members. For character, if you are declaring 1 byte, integer 2 byte, float 4 bytes. So the maximum of these members is float z, that is 4 bytes. So only a total memory allocation of 4 bytes will be allocated for the union variable u. Out of this, if you are using x, this space will be allocated for x, 2 bytes will be allocated for y, and if you are using the variable z, 4 bytes will be allocated for z. So the main difference is in memory location. In structure, all the variable members will be having its own memory location, whereas in union, memory is allocated depending upon the member which is having the highest memory space requirement. Now you can also have character array within a union. Now what's the memory space requirement? For the variable u, total number of bytes would be, here if it is y, it is only 2 bytes. In case of name, it is 20 into 1 byte since character. So 20 bytes would be allocated for the structure variable u. How you will access the members of the union variable. This is similar to accessing the members of structure variable, that is using the dot operator. We will see one example. should be small u. All keywords start with small letters. You are having two variables, int x, int y, two members, and union variable u. How many bytes will be allocated? If x 2 bytes, y 2 bytes. So maximum is 2 bytes itself. Write a main program. You are assigning u dot x equal to 10. That is, using the dot operator, you are accessing the member variable x. You can assign only one value for one of the members at a time. Now what will be the value being printed? U dot x will be 10, U dot y also would be 10. Because the memory space that is allocated is 2 bytes for u. You have assigned u dot x equal to 10. X and y both are referring to the same space. So u dot x will be equal to 10, u dot y will also be equal to 10. Now suppose you want to enter a new value. And you have assigned it to u dot y. Now when you are entering, suppose you have entered the new value as 20. When you are printing u dot x and u dot y, you will be getting 20. Now you are getting the correct answer as the same value because both x and y are of the same data type, integer. If it was for different data type, like if it was a character and an integer, you will be getting different answers. We will see one example later. Now how do you get the size? If you want to know what is the size or in number of bytes that has been allocated for the variable u, you use the size of operator. It is a unary operator. Size of u, the output that you are getting would be 2 bytes. So we learned how to access the variable using the dot operator, how to print the values, how to read the values, how to find the size of operator. Now you can see another example. Here how many bytes will be allocated for the variable u? Plus character 1 byte, integer 2 bytes. So maximum is 2 bytes. So you would be having 2 bytes. In the main program, u dot y equal to 5 printf it would be printed 5. Suppose assign it as d, printf %c u dot x, the output would be printed as d. Now suppose we have done u dot y equal to 65. Okay, what is 65? It is actually, when you print it as character, it is the ASCII value of A. You don't have the statement, suppose. Okay, so u dot y, sorry, here it's y, okay. U dot y 65 will be printed, percentage D. So when you're printing as percentage C, that is character, and U dot X, since it is having the same values, okay, 65. When you're printing as integer, 65 will be printed. When you're printing as character, the character A will be printed because it is the ASCII value of A. We see some similarities and differences and one more program, and also of course the uses of unions. Now we will just compare the difference between structure and union. The keyword used in both is for creating or defining structures we use the keyword struct, whereas for defining a union we use the keyword union. Next is the size comparison. When you're defining a structure, memory space is not actually allocated, but when you're declaring a variable of that particular structure, the compiler allocates the size equal to the sum of the individual members in that particular structure. All the individual members' memory requirement is added up and it will be allocated. Whereas in the case of union, which member has the greatest memory location, that much bytes is allocated for that particular union. Next is the memory. Each member in a particular structure has its own memory location, whereas in case of union, all the members will be sharing the same memory location. For accessing the members in a structure, all the members can be accessed individually as and when required. But in case of union, only one member can be accessed at a time with the correct value. Next comparison is done on the value altering. When you alter the value of a member in a structure, the other members are not reflected. For example, s dot age equal to 20, s dot sex equal to female, and you're printing the value of s dot sex. When you're changing the value of age, the sex value is not altered because they are having different memory locations. Whereas in case of union, altering the value of a member changes the value in other members. Now u dot x equal to 65 and you printed u dot y. Since it is sharing the same memory location, u dot y is also 65 but you're printing it as character. So A is printed. When you change the value of u dot x equal to 66 and you're printing u dot y, the letter B would be printed. Both x and y are sharing the same memory locations. So change in one memory value will be reflected in the other member value. Next is value initialization. All members can be initialized with values. In this example, S is a structure of type S test and you are assigned age equal to 20 and sex equal to female F. In case of union, you can assign only to the first member. Here the first member is integer value x. So you assign it as 65. Next we will see an example for union within a structure. You are creating a union dress ID which has members color and size. Then you are creating a structure cloth with manufacturer name, cost and the description details. And the description detail is that of union, and the union is defined within the structures. You're simply writing a program to print the details, change the value of the union and then print it again. You have created a union dress ID with members color which is a character array and size which is of type integer. You have created a student of type structure with members name, character array, cost which is float, so 4 bytes, and then you have created a member D of type union dress ID. When you're creating a member, of structure, number of bytes allocated will be for name 20 bytes, cost 4 bytes, and for union address ID memory space allocated would be 20. Since the maximum size is either 20 or 2, that maximum is 20. So total, when you're declaring a variable of type student, 20 plus 4 plus 20, 44 will be the number of bytes allocated. This is an example for union within a structure. Here you have declared a structure student S and initialize the values. Manufacturer's name as Peter England, cost 999.95, and the color is assigned as white. When you're initializing the value for a union, it is initialized to the first member. You had color and size. So the first member was color, so white will be assigned to color. S dot name, S dot cost, and S dot D dot color would be printed. How do you access union within a structure? S is the structure name, D is the variable name. So S dot D dot color. The dot operator precedence is from left to right, similar to structure within structures. Now S dot D dot size, you have changed it to 12. Now when you're printing S dot name, S dot cost, it will be printed the same. S dot D dot size would be printed as 12. S dot D dot color would be having some garbage value as output, because this place where white was written has been overwritten by size equal to 12. So either the color or the size can only be printed or used. Here's the output for the program. The name, cost, and color of the shirt has been printed. Similarly, after changing the cost, you have printed it. Whereas you can see some pattern when you have tried to print S dot D dot color. Some invalid value has been printed.